Hey guys, Happy New Year. Welcome back to another video. So, 0.07a is released. It's in the description if you want to try it. You just need OpenJDK 17. And, yeah. You'll have to excuse me because I'm getting over being sick. And, I guess we can just discuss some of the changes. So, a major one, the SQLite map database is implemented for world data. Still got to save your character's position and the direction of their inventory and their health and their name. Well, the name will be their ID, I guess, but anyways. Another thing is OpenJDK 17. I think I already said that, but I'm going to say it again. You need OpenJDK 17. You can get that in Fedora. You just gotta make sure. Oh, you can get that in any Linux distro that's mainstream, but I'm saying Fedora specifically because Fedora has a release of 17, which is not called 17. It's just called Rolling Release Edition or whatever it was. I can't quite remember. But if you're on Windows and you don't have that added in your path environment, you can just CD into the directory and then just do that like that wherever your OpenJDK 17 is -jar and then the jar. So let's just do this. And PowerShell is like, no, you're not playing your game today. Okay, so forget about OBS. There we go. So main thing with the main menu is this re-implemented reduced object calls, more data oriented. And it's got specialty main screen text. I keep wanting to call it the splash screen because I just call that the main menu of the splash screen for years. But it's just the main menu. Then we go into single player, and wow, I already built this house. It's amazing, I know. But in all seriousness, this is from the first take of this video, so just pretend you didn't even see this house. So let's see. Main thing is the new thread design. The thread design is primarily for 2 to 4 core systems. That's where we probably run the fastest, but I need to actually work on the thread system and basically make the threads sleep because they're running every server tick. Or I'm sorry, I've been programming in this game for a little too long this week. CPU steps, basically, like the CPU's loop, its main logic loop. But Java has a built-in thing for that, and I'm gonna mess around with it and make it so it doesn't consume the other threads. So let's see. I already showed you the database. More data-oriented approach. And I know what you're saying. Well, like, how are you gonna data-orient a Java program? Everything's an object, and there's certain ways you can do it. Like, the main thing here is the particles are all data oriented. And even though it is technically a hash map, which is object oriented, taking a data oriented approach has made it easier to handle the particles. So the particles are basically an abstraction. They're implied that they exist. They don't actually exist. It's just keys and values. So every particle you're seeing is just an accumulation of a bunch of variables. Wow. which, you know, I guess if you want to look at that from an over, like, really far out there, I guess you could say that's an object, but in memory design, memory optimizations, that is quite a big difference due to memory allocations. So you can see the darkness spots. Still looking on to fix this, but oh wow, I fixed it. Look at that. It's a miracle. Let's see. Oops. So I put that down lower to show you. And of course I'm going uphill while I'm trying to show you. The chunks loading don't cause lag, because SQLite is its own thread. Yay. And the thread optimizations are implemented. Basically, the last thing I was doing was willy-nilly, oh, let's just throw threads at it, but this time I actually did a design for threads, and you can see I have actually broken the renderer for the water, but I'm going to fix that. You see, boop, pops into place. Pops into place. So, I cranked up the chunk update amount for maximum updates, basically. And, it's still quite playable. So I'm pretty happy with it. There's no mobs. Mobs need to be redesigned completely. That's a whole can of worms. I'll get to that when I'll do an update video when I do the release that have the mobs in it, because they need a complete rethought, redesign. That's after implementation of database structures of where you are, who you are, what you're doing, what you have in your hands, basically, what your health is. So, pretty simple though. It's just I'm gonna have to make another table in the database that has player files, and then make a couple of columns that have your player information. You're like, who are you? Oh, your ID is single player. Amazing. I can't believe it. So you can see that sometimes it does have a soft stutter, and a soft stutter is like a micro stutter, basically. That's because of allocations in the memory. I'm also playing on the max render distance, which I usually play on 7. But basically, what was happening before with the willy-nilly, completely just randomness, like unthought about thread implementation, is that would cause hard stutters. Like, you would drop like 20, 30 frames, and you'd be like, oh, this game was programmed by someone with a negative age. This is amazing. But it's better now. I'm really happy with it. It actually ran a lot smoother on Linux. I tested it in Fedora workstation, and I was actually like, whoa, this feels a lot different. So it's going to be the Windows kernel's thread task scheduler. Thread scheduler? Task scheduler? I don't know. Whatever it is, it's a proprietary operating system. That's a secret. I don't know what they call it. Let's see. The only thing that is bad is I broke the... I already showed you that. Sorry, this is like the second or third take of this video, but... Anyways. Yeah, that's about it. The sun's there, and it gets dark out, and it becomes light out. And your character's there, and there's new digging animations. Amazing. Place an item. Or you place a block, I mean. Only thing I'm not happy about is the tool animation. It looks like poop. And I don't like it. And I'm gonna change it. Also, the game volume is too loud, but it's too late. I'm not making another take of this video. So let me just show you this. Oh god, I don't want to look at it again. Oh my god. It's like, I don't know what it is about it. It just looks terrible. Who swings a pickaxe like that? Let's see, data-oriented approach, something. I think I don't remember if I said it in this take, but data-oriented approach. So, it's like a hybrid approach between what I learned in Rust and what I learned in C++ and C, and I tried to implement it into Java, and it actually made a very large performance boost. So I guess I can show you that now. Let's go to the IDE. If you don't want to watch the IDE, feel free to quit the video, I guess. It's up to you. I don't know what you do. You do you, I guess. Okay. This is like the best way I can explain this is what I'm doing with all these commits that I'm saying, like, oh my god, it's data oriented. Amazing. Okay. 1 second. I'm gonna get some resources. Wow. Resources. But anyways, okay, see this. This is beautiful. But besides the fact that it's beautiful, this is an object. So this is its fields, basically. Like its internal variables. And 1 second, I need more resources. Okay, I'm back with resources. Okay, so this is my program. Wow, this is that. Alright, there you go, beautiful. This is my program. Okay. So my program needs a particle. So it goes into that class, which we'll just say it's C. And then it's like, okay, let me assemble this object. That's beautiful. And then the object is taken. And then it's like, okay, there you go. It exists in this program now. Wow, that's incredible. Okay. So now let's say this is now data oriented. So my little class now has these neatly packed pieces of data. Okay. And it's like, I need your position, I need your thingy, and I need your who's-y what's-it. And then the program is able to decipher this and be like, okay, that's easier to access. And this is pretty much a horrible oversimplification of what I'm trying to explain, and it also probably doesn't explain anything at all. So let me just show you what I mean. So in memory, when you have an object, and I'm pointing to the screen like you guys can see it, but in memory, when I instantiate an object, instantiate, whatever it's called, this now becomes basically a container, right? And so I have an array map of these particle objects. And when you're doing simpler stuff, it's easy to do that, but it becomes a spaghetti tangled monster mess, because basically this is a constructor, that's a constructor, and that's a constructor. This object has 3 constructors that literally don't need to be like this. It should be 1 constructor, okay? And so now when this thing goes through your particles, it has to go to the memory blob and access all these data variables, which honestly might not even be next to each other in memory. So it has to keep track of these variables, and it's just it becomes a mess really quick in memory. And it's very hard to explain with just code, but with the back end of how object-oriented programming works. If you object-orient program in an object-oriented language, you can cause quite a conundrum. That's all I'm saying. So this is what I mean when I'm saying those particles actually exist as an object. Oh, it's a literal. Oh, it's an object. Okay, it's one of these things. But what's happening now is you have a bunch of hash maps which do use an integer object. This is not a primitive. This is an object, and this is an object. But these objects do not exist as any lone object. It's easier to put them in memory because you don't have to pack in random variables next to each other. So, like, if you had a vector 3 next with vector 3i next with vector 3f, there's no way to, like, make that work. Okay, this is a really bad explanation. I am so sorry. But there's no real way to make that, like, fast. And there's also mutability issues. And etc., etc. Like in that example that I showed you with the objects, one of the biggest issues is that because I was holding those objects in an array, all of their variables had to be public for this container to or this class to access the container of the containers of variables. But now I can just simply tell this class, hey, these are the particles. No other class can access these data variables. And if they do, they have to go through this class to get them. So that's what I'm trying to get at. And in doing that, it will tend to make your program run faster, basically. And that's why I'm doing it. It also has better thread safety because mutability with object-oriented programming and concurrency becomes it becomes not good when you have object-oriented design with multi-threading. So yeah, that's basically it, I guess. And that's why in the chunk mesh generator, wherever I put it, you can still see that there are some objects in here, but there's also an insane amount of primitives, like primitive arrays, because I like to, when I'm passing chunk data to the chunk mesh generator or having it access it, basically the more data oriented your programming is, the easier it is to understand the abstraction between the two threads. That's probably the wrong thing that I'm trying to explain, but that's the only way I can explain it. But yeah, that's basically it. That's what I'm trying to do. I'm trying to stay in the object orientation of, like, the class is an object. This is an object container for this object and this object, because this is not a primitive. This is a capital I. That is an actual container of a float. But, I mean, a float, an integer. But it makes it so down the line, mutability doesn't become a severe issue. Like, you treat the data as if it were super secret data. And that way you don't have pointers mixing and matching together and causing severe issues. Let's see. So like here, this is a actually, this isn't mutable. This is a primitive. This is what I'm talking about. Like, when I am accessing in the class all private variables, you want to make sure immutability is key, so that way you don't have pointers going everywhere. And some things you can't really do that. Like the mesh is an object, and you can't abstract that into a data-oriented design, because the mesh is like a key part of the one second, let me think about this for a second. Okay, I understand what I'm trying to say to you guys. So you can't abstract that into a simpler container, basically, because the mesh is the container of this. It is an object in itself, which needs to be extracted to render it. Like, let's say I wanted to data orient meshes. What I can do is I can data orient the mesh class, which, God help me, that would be an absolute nightmare, but I could do it. Maybe down the line I'll do that, because that might actually be quite a performance boost, but for now, there's no way to extract this into a simpler, like basically a lower level, more to hardware data type, because it needs to call the render. This is what this actually does in the rendering class. It just gets the mesh, and then it is able to directly call render from this getter, because it's being passed the direct object. So unfortunately, the way that this is designed, that's possible, but that should probably not be possible. So I'm actually going to think about data orienting this. This might be a nightmare, though. Yeah, that's pretty much it. Now I'm gonna have to experiment with data orienting the mesh class, because honestly, that'd be kind of cool to be able to just store an integer of a mesh in a hash map and be able to call all of these and keep this list synced together. But that is definitely for another video or another update video or something, because there is a lot of dependencies on this. There are a lot, like literally the whole game depends on this, but I really want to try that. So anyways, guys, I think I've rambled enough. It's 23 minutes. And hopefully you at least enjoyed this. If you're still around, you probably clicked out the video a long time ago. But anyways, hope you have a happy new year. Don't try to celebrate too hard. And I'll catch you in the next video. So peace out.